The goal of this video is to be able to find the area of a non-right triangle. So basically, after you watch this video, you'll be able to find the area of any triangle, no matter what, without exception, which is what this diagram represents, just any triangle labeled the way we've always labeled it. All right, so here is our first formula. The formula is, given any triangle, labeled the way we've labeled it, given a triangle ABC, the area is actually going to be 1/2 BC times sine of A, or 1/2 times AC sine of B, or 1/2 AB sine of C. And the proof I'll actually show you is basically just 1/2 the base of the triangle times the height of the triangle. So the sine piece is actually a substitution for the height. So I'm actually going to show you that. But before I do that, I want you to know when can I even use this formula. So I'm going to show you when you should try to use it, if you choose, because there's always more than one option of finding one way to find the area. And then I'm going to show you where the formula came from. Okay, so here's what we got. If I'm going to use this first iteration of it, that's basically right here. So side angle side, it's always side angle side when you use this formula. You're given two sides, in this case B and C, and then angle A, which is where you find sine of angle A. So side, angle, side, boom. Let me show you another iteration of it. So if I want to use, for example, this iteration, I would have two sides, A and B, and then angle C. So I would have 1/2 times A times B times sine of C. So using this formula is really easy. You just have to know when to use it and how to substitute the values in. You've got to be kind of careful with that. All right, so here's the proof. It's a really basic proof. So really all you have to do, and we've done this before, is drop down an altitude. So the actual height of this triangle, 90 degrees. It's called drawing a perpendicular, right? So from one vertex, in this case vertex B, I'm going to drop a perpendicular. And that's actually our standard to derive the formula for the area of a triangle by drawing this auxiliary line that is a perpendicular from a vertex to the opposite side. And of course, I'm going to call this H. So I'm starting with this assumption in my proof. I already know the area of a triangle. The area of a triangle is half of a rectangle. So let me sketch the rectangle. So basically, this area that I'm shading red is half of the rectangle. Well, the area of the rectangle is length, which is B in this case, length times width, which in this case the width is H. Well, the triangle's half that. So that standard area formula for a triangle is 1/2 base times height. So 1/2 B times H. That's pretty standard. So now I'm just going to prove one of those three expressions. So we have, of course, all three expressions. I'm going to do one proof using one portion of the sketched triangle, and you could do the exact same proof for the other two. So I'm just going to do the one. All right, so here's what we got. I know, okay, so this is where the substitution comes in. Let me change the color to make this kind of stand out. I know that sine of A, this is going back to the definition, so I know that sine of angle A is, so I'm looking at this triangle here. Let me make it green so it pops. Sine of A is the opposite, in this case H, over the hypotenuse, which is C. So I know that sine is H over C. Well, if I solve for H, I'm going to multiply both sides by C. So I have C times sine of A equals H. Then I just make a substitution in the area formula. So the area formula is 1/2 base, which that's B, times the height. Well, I'm going to replace H with C sine of A, and that's one of my formulas. Okay, so that's if I'm given two sides, B and C, and the measure of angle A, I can find the area of this entire triangle. The area of the entire triangle is 1/2 base times height. I can replace H with C sine of A. So it's basically just straight definition of sine, dropping the height, the altitude, the auxiliary line that's perpendicular to the opposite side from a vertex, and that's the proof. So it's a really basic proof, one substitution using one definition, all starting with the assumption that we already knew how to find the area of a right triangle, make a substitution. So that's the proof. Now the rest of this video is just how to use the formula, which is really basic. So I always like to make sure that the last lesson before a test is a really easy lesson. So here's the lesson after the proof. Okay, so once again, if I'm given two sides, so side X and side Y, and then not angle X or angle Y, but in this case, angle Z, we can use, that is a side angle side list of three parts, so I can apply this formula. I'm going to make a sketch just so you can see it, because it's completely arbitrary in terms of how I label the triangle. So I'm going to call this X, Y, Z. All right, here's angle X, so side X is over here, which is 15. Angle Y is here, so side Y is here, which is 23. And then angle Z is here, which is 65 degrees. So you can see side, angle, side. Dive straight into the formula. So the area formula says 1/2 times one side times another side times sine of an angle. Okay, so it doesn't matter what we call A or B or C. In this case, we're actually doing 1/2 times X times Y times sine of Z. Okay, so once you make a sketch, honestly, all you're doing is 1/2 times 15 times 23 times sine of the given angle. It's a really easy formula. 1/2 times 15 times 23 times sine of 65, which is approximately 156.338 or 34. And just remember, it's area, so these are square units. So if this were centimeters, this would be square centimeters. I'm just going to write units squared or square units. I don't know what the unit of measurement is. Easy peasy, guys. Okay, so that is how you find the area of a non-right triangle using side angle side. Boom, there it is. Now, there's another formula which we're not going to prove. The proof is pretty elaborate. If you want to go to Wikipedia or YouTube and just kind of follow the proof involves the law of cosines and multiple substitutions and a lot of algebraic manipulation, but it's not bad. I mean, you could read it and follow it, but it's a long proof, and this is kind of beyond the scope. But it is really important to be able to know this formula. It's an SAT formula. So if you're given three sides of a triangle, the cool thing about this formula is it doesn't depend on angles. So you can just be given the three sides of a triangle, and you can find the area even if it's not a right triangle. So the formula is called, I've heard it pronounced Herons, I've heard it pronounced Herons Formula without the N, I've heard it pronounced Heron where the H is silent. So Heron, Aaron, all kinds of pronunciations, and people can debate this. So I'll call it Herons Formula if you want to call it Aaron's or Herons Formula, whatever. So the formula is pretty basic. The area will be the square root of S times quantity S minus A. A is one of the side lengths. Quantity S minus B. B is one of the side lengths, times quantity S minus C. And then S is defined to simply be half of A plus B plus C. So, I mean, it's pretty basic. So, the first thing I do is I find S, so I can just substitute everything directly into the formula. So, S in this problem, given all three side lengths, is going to be 1/2 the sum. So, the sum is 8 plus 6 plus 4.1, which is, and then of course be careful, you want to add all the three sides and then take half of it. So S in this case is 9.05. Okay, so the area of this triangle is going to be the square root of 9.05 times 9.05 minus A, which is 8, times 9.05 minus B, which is 6, times 9.05 minus 4.1, which is C, which gives us approximately, which is approximately 11.9776, or to the nearest hundredths, 11.98. All right, guys, pretty straightforward, very short video. I just want to remind you that given any non-right triangle, if you're given two sides and an angle, you can find the area. If you're given all three sides, you can find the area. So you can find the area. I think I said angle. You can find the area given SAS or SSS. All right, guys. Keep studying now. You're ready for our next test, which is over. Law of sines, law of cosines, a few word problems involving law of sines and law of cosines, and finding the area of a non-right triangle. Have at it, guys. See y'all in class. Be safe. Be well.